So this is 1.7b in elementary algebra, and let's go ahead and continue with examples. We're in example 6 now, and what they're asking us to do is simplify each expression. So the first one is 10 times x over 2. And again, if it helps to make this into a fraction, just to remind you that you're taking numerators and denominators, and then you look at the number. 10 over 2, or 10 divided by 2, is 5. And you're done with that one. And the b part of this is a times 3 over a, and then we're subtracting 4. So we're distributing again. So again, let's make that into a fraction. So this would give us 3a. 1 times a, anytime you take a letter or a number times 1, it's just itself. And now we're going to take a over 1 times negative 4, and let's make that a fraction. So we have a, let me change my color, a times negative 4 is negative 4a, which that's what this is. And 1 times 1 is 1. And we don't even need to put that on there. So we end up with 3a over a minus 4a. And one of the things that you'll notice here is I have an a here and an a here. And remember what I said as far as letters or numbers? If we have 3 over 3, that equals 1. 6 over 6 equals 1. A over a equals 1. And if that's the case, we don't even need to show that because they're both 1s. It would actually be any number over itself is 1. So we don't need 1s. 1s don't do anything. So our answer is actually then, when all is said and done, 3, because we got rid of this a here, minus 4a. And because this has a letter attached to it, and when I mean attached, when there's no symbol, this isn't 4 plus or 4 minus, or 4 divided by, there's no symbol there, so it's an assumed 4 times. When 4 and a are attached, you can't say 3 minus 4, because this isn't 3 minus 4, this is 3 minus 4a. This is one piece right here. So you leave your answer just like it is. Alright, so let's get into some special numbers here. And these special numbers have to do with zeros. And the property is the additive identity property. Pretty much, and you're going to be like, oh duh, when you add 0 here, you get 5. If you were to switch those around, you'd still get 5. Okay, and what they mean by additive, it means that you can add 0 to anything and it does not change the identity of that number. That's why it's called the additive identity. You can add 0 to any number or any letter, and the answer will always be that same number and letter. And that's like one of those duh moments. But when you get into upper level math, you use that to your advantage. It will become a very important part of what you're doing in the future. So just accept it as truth. You already know it is. It'll only make sense. But later on, in this course even, you'll be doing some things where that's important to remember. And I'll remind you. Now, this is why you learned the additive identity property. The same is true with multiplication. The only thing different about the multiplicative identity property is that if we take any number times, not 0, like we added 0, any number times 1, we're going to get 5. Or 1 times 5 is going to give you 5. So you can multiply 1 times any number or any letter, and you'll get your original number or letter. So in addition, you can add 0 to anything. In multiplication, you can multiply 1 by anything. And there's also another property called the additive inverse property, which means if we have a number and we add its opposite, we will always get 0. Okay? And finally, we have a multiplicative inverse property where it says if we take 5 times its inverse, because this is 5 over 1. We flip it completely over and we multiply. We get 5 times 1 is 5, over 1 times 5 is 5, equals 1. So the multiplicative inverse property says if we multiply any number or any letter, if we multiply a times 1 over a, we will always get 1. So anytime we multiply a number or letter by its inverse, where we flip it upside down or take the reciprocal, we will get 1. Okay? So those are, again, like I say, important to know how to use. They are not that important to know the names of them, to remember, oh, what was that? The associative property. What does that say? Just know how to do it. That's the key thing here. And I'm sure some people would disagree with me, but example 7 gives you some examples of stating the property given a statement. So x plus 5 equals 5 plus x. That's the commutative property of addition. So just remember that for the homework. All right, so problem set. Still have some time. Let's see if we can find some stinking hard ones. Well, let's look at number 23. They're just asking you to look for the problem there. Notice 9a, or find the mistake. They're all problems, aren't they? They give you this, and they're saying, okay, what's wrong here? Well, what's wrong is they multiplied 9 times a, but they didn't distribute and multiply 9 times b and get a 9 there. So that's what they're looking for. Find the problem. Find the mistake in those. 31 to 48, use the associative property to rewrite each of the following expression. Actually, if you look at like number 33, they're just asking you to regroup those and then get x plus 9. Okay, so that's what they're asking for there. Same is true with like number 46. They're just telling you multiply the two numbers together and then simplify or solve this. 6 over 6 is 1, and the negative carries along with it. And you don't even, you can leave it as negative 1x, but you can also just take the 1 off and leave it as negative x. That works too. All right, 49 through stinking 92. Apply the distributive property. So let's get some hard ones here. Let's jump all the way to 92. So we have negative 3, 4x plus 5 minus 20. I like to do the harder ones as examples from the homework because it always seems like the book and the explanation and the lecture, they just give you easy ones and then they slam these hard ones in the homework and you're like, what the heck? I don't even know how to do these. So at least if I do some of the harder ones, then the easier ones will be no challenge. So distribute. Negative 3 times 4. Negative 12, and you tag the x on. Negative 3 times positive 5. A negative times a positive is a negative. And then when you do all that, you take the parentheses off and put a negative 20. And then we can combine those. And if you still need to do it, that is absolutely fine. Make that into a plus negative 20. And then we can look here and say, all right, the largest number is negative. And the signs are the same, so I just add those. And I call that good. Negative 12x minus 35. All right, so the next section, I'm not really sure why they do this in this book, where they give you problems that you're not supposed to know. Here are some problems you will see later in the book, and we're not going to tell you how to do it, but we're going to assign a buttload of them for you to do without telling you how to do them. Let's take 95 first. That one's kind of a pain, isn't it? And again, it's just doing what's in the parentheses first. 1/2 times 3, or 1/2 times 3 over 1. So you multiply the numerators, multiply the denominators, so we combine those two, and then we square them. And remember, when you square what's in parentheses, you square the top number, and you square the bottom number, and you're done. Alright, so let's look at some of these other ones that you don't know how to do, but they're expecting you to do. I know I got an attitude, don't I? It just seems kind of silly to give you problems that you're going to see later in the book. Let's do 113. Okay, so we're going to distribute, and I'm going to make these into fractions, just so I remember. Then I'm going to multiply the negative 1 times the negative 2 and get a positive 2, and the x just tags on. And then 3 times 1 is 3. Notice, and this is something I want to make you aware of. Notice right here, I've got negative 2, and I made it over 1. Where does the x go? Does the x go on the top with the 2, like this one? Or does it go like that? It doesn't matter. Those both mean the same thing. But this does not mean the same thing. Okay, you can't do that. If the x is on the top, or if it's next to, that's okay, because that means when the x is here, that means it's actually on the top. So the x is always going to be on the top. If it's like a whole number like this and you make it into a fraction over 1, that x stays up there with the original 2. I hope that isn't too complicated, but anyway, that's the way it goes. Let's say this times this. So again, the negative 1 times the positive 6, negative times a positive, 3 times 1 is 3. So that gives me 2x over 3, or if you'd rather write it, 2/3 x minus 6 over 3 is 2. And you get that for your answer. I don't really think there's anything else that's too crazy harsh. Got some story problems there. I don't know that I assigned any of those. I don't have my website. Let's see. Yeah, I really don't care about 125, 126, 127, 128. Yeah, if I did give you any story problems, 125 to 129, don't do them. And that way I'll know if you even watch this video, because the video is the only place that's going to tell you not to do those story problems. So if you do them, I know you didn't watch the video. Alright, so let's do 122 and then we'll stop. Alright, so we're going to distribute a times 1. Anytime you multiply a letter or a number times 1, it's itself. Now let's multiply it by that. So let's make it into a fraction. A times 1 is negative 1a. 1 times a is 1a. And because this is the same and this is the same, we can cross those out. Now this is where it gets a little tricky. When you cancel everything out like that, it is not a minus 0 or just a. There is always a place value of 1 there. Okay, because look what we did here. We had 1a over 1a. What is a over a? It's 1, right? What is 1 over 1? It's also 1. So we have a minus 1 times 1, which is 1. Okay? So a lot of times what students will do is say, oh, we'll cancel those. Oh, we'll cancel those. That's not what you're doing. You're just turning them into 1s. And then that gave you 2 1s multiplied together, which gives you a minus 1. So hopefully that makes sense, that whole a minus 1 thing. And that's it for 1.7b.